Hi, I'm Matthias. I come from Austria, nearby Vienna, where I live with my wife and 2 kids. They are probably watching the live stream now, so hallo Liebe. Okay. As part of my work, I build collaborative web applications on top of a peer-to-peer, distributed, offline first, innovative, awesome graph database written in Elm. So if you're interested in that stuff, get in touch with me. You can reach me on Twitter or on GitHub. But today's talk is about something completely different. It's about Dive, Prezi-like presentations in Elm. And as you might know, Evan was working at Prezi for some time, and he was working there on Elm full-time. But by the time then when I was starting this project, which was in November last year, Prezi was still based on Flash, at least the presentation tool itself. So there obviously wasn't much Elm code running on Prezi. But actually building something like Prezi in Elm seemed to me the most obvious thing in the world, because Elm gives us all those powerful abstractions to build visual and reactive, interactive applications. And that's what I did, kind of as a proof of concept with Dive. And it just took me a couple of hours to create the core framework for Dive. My talk actually consists of 2 slide decks, each featuring a different approach on this topic. The first one, this one, is based on HTML5 Canvas, to be more precise, on the Elm graphics library Evan wrote. And the second part will feature a SVG-based approach, and I will compare these two. And finally, I will show you a neat little web tool where you can easily create a Prezi-like presentation. My talk is pretty straightforward, so and also doesn't take too long, so I think you will make it even if you are already hungry. Okay, so let's dive in. So what would the model for a Prezi-like presentation framework look like? So our model consists of a list of objects and frames. Let me illustrate that to you by an example. So we have here a text object, hello world, and an image object, this world pic. Actually, the fonts are not aligned with the image because it is not installed on this machine. I should have embedded it. Don't bother. And we have 3 frames defined here in this example. Currently, we are on frame number 1, which are these red rectangles. And if we proceed through our presentation, then the canvas, the list of objects is scaled up so that it fills our viewport. So that everything within a frame fills the viewport. So now we are viewing the word hello, and on the 3rd frame we're getting this image object into focus. So what does that look like in Elm code? First, you define a list of objects. Here we have a text object. These are functions from the Dive API, by the way. And an image object, they get several decorating functions, and they get width and height and the position and the file reference and stuff like that. And the second thing you need to define are the frames, a list of frames. A frame has a width and a height and a position within our canvas. And that's what all you need to do to build a Prezi-like presentation using Dive. So our model has this list of objects, which I call the world, and it has a list of frames, and it always has one current frame. That's the frame we are currently viewing on. A frame consists of x, y, width, and height values. And the third thing we need is the transition state. So when we are moving from one frame to another, then we have a transition. So we might have a transition, we might not have one. So this is a 0-1 relationship. And a transition has, let me try this, a target frame and a progress value between 0 and 1, which is kind of the state when we are moving from one frame to the other. Okay, it's a quite easy model, I think. So that's what it looks like in Elm code. The world, the list of objects, the frame, the list of frames, the current frame, the transition, which is of type maybe, and the viewport, which is the size of our browser window, which we need in order to scale a frame relation to this viewport. Okay, now what does our view look like? It's a really neat function. It gets the model in, it transforms the list of objects using object to form. What does object to form do? It deconstructs the object and maps its parameters onto the respective function from the Elm graphic library. We turn it into a form because that has historical reason why this is there, and finally move it to its respective position. So having this list of forms, we apply the group transform function from the Elm graphics library, which takes the transformation matrix as its input. The transformation matrix is calculated by transform. Depending on whether we have a transition or not, we either take the current frame or we take some intermediate frame between the current frame and the target frame given the progress value. And having this frame, then we calculate the transformation matrix, which matrix actually does, just math. Okay, then we have one group of transformed objects. We wrap it into a list, pass it on to the collage function of the Elm graphics library, and then we're done. It is rendered to our screen. The canvas is scaled up respectively to the frame we're currently viewing on, so we get those parts scaled up on our viewport. So what does it, now for the update part, just a simplified version. We have just a resize message. So when we resize the window, the fourth message is we want to go forward in our presentation, and the tick is for rendering transitions, so when we're moving from one frame to the other. These messages come into the application through these subscriptions. So we just subscribe to the Resizer subscription, we subscribe to the mouse click subscription, map it to the fourth message, and we subscribe to, and I really love that subscription, animation frame. So when we have a transition, we subscribe to animation frame.diffs, which gives us the time deltas between the previous animation frame of the browser and the current animation frame of the browser, map that value to the tick message. And this, I loved it that we can write such a thing declaratively, actually, and do not have to dabble with request animation frame, subscribe to that, unsubscribe from it. It's just 3 words here. I forgot to say that I usually give this talk in order to introduce Elm to people who don't know Elm, just to demonstrate what you can do with Elm in a few lines of code. And for the update part, pretty straightforward. When we have a resize message, we put it into our viewport. When we have a fourth message, then we get the first frame out of our list of frames, put it into the transition state, set the transition, the progress value of the transition state to 0. And if we get a tick, so if we are rendering the animation, then we calculate a new progress value given the old progress value in relation to this time delta and the duration it takes to transition between frames. And then if the progress is below 1, then we just update the progress value, and if it is equal 1 or bigger, then we set transition to nothing. And that's it. finally, we wrap all these parts into this effect manager HTML program. In the init, we define our presentation, the world and the frames, and that's it. That's how this presentation itself is built, by the way. Okay. So this is the Canvas approach. As you might have noticed, it has two issues. The first is performance. It lags a bit. It is not so smooth because Canvas is made for pixel drawing, and if we are scaling a lot, then we are doing something with Canvas which wasn't probably not made for. And the other thing is, it is hard to create a presentation in Elm code. I mean, Elm is awesome, but if you to create this presentation took me a day. Creating the framework took me 3 hours. So it's not really fun to do. And one would need to write an editor to create a Canvas-based presentation, and this is also quite a lot of work to do. So I also got into this other approach using SVG, which is actually much better because SVG stands for Scalable Vector Graphics, and that's what we're doing here. We scale stuff. And yeah, that's what I'm going to show you now. If I make it. So, yeah, the code got even shorter. So that's another talk I gave in March, porting Prezi to Elm 99 lines of code. And yeah, it's pretty much smoother. Here we've drawn this nice picture of the Elm architecture. Again, it was also an introductory talk for non-Elmers. And let me just let you show the differences between to the previous approach. Here we have our model. What is missing here is the list of objects, of course, because our presentation now lives totally in the view in the SVG function. And we only have to deal with the frame and the transition stuff. So that's again what it looks like in Elm code. Just the world is missing effectively. And also the viewport is also not there anymore because we can set the SVG element to auto-scale to the viewport width and height. I'm going to show you this now. So what does the view look like? We are using SVG, and SVG got this amazing property viewbox, which exactly does what the scaling function in the previous approach does. We can define portions of our drawing which we want to be scaled up to our SVG element. So if our SVG element equals to the viewport width and height, then we can scale up the part within the red rectangle up to our SVG element, which is equal to the viewport. And that's what it looks like in HTML. SVG element width height set to the viewport, 100% width and height, and this viewbox parameter gets the position and the width and height of this part on the SVG drawing, which we want to zoom into. And inside of the SVG, there is our presentation content, a circle. Just shortly, what does it look like in Elm code? We just concatenate the values of our current frame and pass it on to this viewbox parameter. And that's all we need to do. No scaling calculations anymore. And our presentation content lives here in the body of the SVG element. So now subscriptions, respectively messages. We don't need the resize message anymore because we are auto-scaling our SVG element to the viewport's width and height. We're just having the fourth and tick. They both, there hasn't been any change actually. We still subscribe to clicks and the animation frame depending on the transition state. So that's it. Update also pretty much does the same as in the previous approach. So as you might have noticed, it is much smoother. But if you get more and more SVG elements into your presentation, it also starts to lag. So you better don't use it for 2 hours presentations. What still is an issue is creating the presentation, because you still have to code it in SVG, in the Elm code. It's also not fun as it wasn't in the Canvas approach. But I've created a little function here which parses an XML string. SVG is XML. Using this STKB Elm XML parser library. It is not published to the package system. I don't know why, because it is a great package. It's using the parser combinators, which is also a great package, because we can write parsers like rules. It's so readable. If you ever need to parse something, use the parser combinators. And the XML parser parses XML into an abstract syntax tree. And what I do with this load function is the following. You give it, I've created a little web tool, I mentioned that. Oh no, this is this weird keyboard. Okay. Let me just, right. So, I hope that was the right shortcut. No, it was not. Oh God. Thibault. Okay, I just get back into the presentation later. It's okay. It's over now. I already killed my previous presentation. So that's the web tool I created. Okay. No problem. You give it as the XML string you give to this loader function, to this load function, has to be this way. So you create your presentation content, and within the SVG you draw in the form of red rectangles grouped with a number the frames. So you drop it in here, start it, the red rectangles are removed, turned into frames, and then you can navigate your presentation this way. And now I try to get back to this. Just a few words on okay. I just had to extend the model by the slides field. So the load function also creates this SVG function, which takes a frame, which is our current frame, and we can, and the view then just calls this slides function on the current frame. And that's it. So here you have several links to the source code. The Canvas approach, the SVG approach, the web tool. I also created an Lightning Talk proposal gist, or GIST, I don't know how to pronounce it, for the ReactiveConf in October. I would like to present that tool to the Reactive community to spread the word of Elm. So I beg you to star it, to upvote it, so that we can spread the word on Elm. And you can also follow me on Twitter, of course. Thank you.
Thank you, Matthias. Any question?
However, I just wonder, I saw that you are using list of the frames in a model as well as maybe which represents current frame. Is that correct?
Sorry, did you get the second part?
Yeah, sorry. You're using a list of the frames as well as maybe which holds like the current frame, right?
Maybe it's for the transition, not for the current frame.
I think that I saw in like...
just that...
Current.
Current is not
okay, so I just wonder, don't you think that maybe it will be better to use something like a non-empty list implementation directly on frames, or even if you then want to go like back and forth, then maybe something more complex on like the data structure.
Yes, actually, you would need to, if you want to go back and forth and do other fancy stuff, you might build a bit more complex. But to keep things simple, I reduced it to the, as I said, it's also meant to be an introduction to non-Elmas. But yeah.
Yeah, okay, I see.
And
Thanks.
it's also to demonstrate the use of maybe, for instance.
Yeah, like okay, like this thing like looks like almost like non-empty list implementation or just coupled inside the model itself. So,
Sorry, I didn't get it.
can you hear me? Sorry, I just said that it's almost like the non-empty list implementation, but it's like the coupled with the model. And yeah, I don't know, like I found myself that this is, many people doing this mistake, like instead of focusing on data structure, they are just putting everything in the model. And I think that we are maybe missing some more complex data structures, like, you know, non-empty list, not necessarily in the standard library, but at least like as a package.
Yes, there is a package, non-empty list.
Well, maybe maybe
use that.
I haven't checked.
Yes,
Like,
probably you mean that list of frames could be empty and then we have no presentations. But at least we always have one frame, so...
Yeah, like it can't be because you still have to have that frame, but yeah, whatever. Like, I had that. I thought that at least at that first part you have that maybe thing as a current frame, and like my point is that what I'm missing here is if you have any reason why you decide to do this instead of using like data structure, which has to have had basically.
No, it's actually, my have had is the current. So it's kind of this data structure. But one could use non-empty list here and would also be a feasible approach, but it's not so, as I said, it is also introduction to non-Elmas. If I start with a community package, they probably lost at the first slide.
So I think we are done. Thank you, Matthias.